Okay, so before we begin, first let me introduce myself. So since I will be handling the first 3 weeks of this lecture, so first let me introduce myself. So my name is Mohd Azizi bin Mohd Ariffin, and I'm from Department of Computer Technology and Networking from UiTM Shah Alam, Malaysia. And my education background is in data communication and networking, and for my master's I do in cybersecurity, and my research area in the cybersecurity, cloud security, anomaly detection, IoT, and network automation. So that is my email and website. So if maybe you want to know me better, you can go to my website, where in my website there is a LinkedIn account, a YouTube account, where you can get all the lectures materials. So this is a bit about my
Sorry, Pak Azizi.
Yep. Sorry.
Is this session recorded?
Yes, I already record the session.
Okay. Thank you.
Thank you, teman. Yeah. And
yep. Tak apa ni share screen.
Oh, sorry, minta maaf. Thank you. Sorry. So again, my name Mohd Azizi. So as I already told you, and that is my website and also email if you want to get in touch with me later on. A bit of my past experience before I become lecturers. I work in several private companies, and this is my certification for teaching. So I do a lot of certification in Cisco. So since UiTM is one of the Cisco Networking Academy, so from the certification, so I done a lot of certification in networking and computer security, right? Okay, so without further ado, let me share my. Okay, so let's begin with the first lecture on the first topics, which is introduction to socket programming. So for UiTM student, for networking student, right? So we already learned about TCP/IP, so which is the the fundamental of what we learn in networking, right? So before we can begin to know about socket programming, so first let us recap back what is TCP/IP, right? So in modern computer system or any electronic devices which communicate through the internet, so all of these devices are communicating via a standard protocols known as TCP/IP. So if we let's Google it. So we just recap. Right, so most of the modern computer system, if they are communicating via the internet, it will follow the TCP/IP models, right? The same standards. So why all of these hosts need to communicate based on the same standards? Because irregardless of your vendors, for example, if your computer, the brand of your computer is HP, or for example Dell, or you can using Apple MacBook, Android phone. So in order for all of these different devices to communicate with each other, it need to follow the same standard, which is TCP/IP models. If not, for example, if HP or Dell are creating their own communication standards, so that means if you are using Apple MacBook, that means you can only communicate with other Apple MacBook. So you cannot communicate with other computers. So that's why we are using the same communication standard, which is TCP/IP models. So based on the models, there are 4 layers. Actually, some people say it's 5, but based on this diagram, to make it simplified, there is 4 layers, which we have application layer, transport layer, internet layer, and network access layer, right? So where sockets come in? So socket is actually abstraction of the interface which allow interaction between the application layer and the lower layer in the TCP/IP models. So that's mean us, such as if we want to develop an application, for example, for example, we want to create file transfer protocols, right? For example, so these protocols, so in order for it to use the lower layer protocols, so it doesn't need to reprogram or redo all of the lower layer protocols. So to make it easier, in most of the modern operating system implementation, they will provide socket API. So where the developer for the upper layer application, for example, file transfer protocol, they just need to access the socket API so that they can use the transport layer, internet layer, and the network access layer. So they doesn't need to redo all of that, right? So we will in this lecture, we'll focus more on the socket layer, how the application layer can interact with the lower layer protocols, right? And how it works. So that is the fundamentally what we do, what we learn in this lecture, right? So I hope that everyone can bear with me, right? So if you guys have any question, so maybe there is some things that are not clear, so feel free to stop me, or maybe my lecture is too fast, so maybe you didn't understand about what I'm saying. So please do stop me and ask question. I really happy to answer all of your question, right? And it also will make this lecture a two-way communication. So anyhow, so here it is. So what is socket, right? So in its literal name, so literally sockets is specially made or specially shaped holes or set of holes which something is fitted. For examples, we can say that let's example in our house, we have electrical sockets, right? So for example, if we want to power up our laptop, so we have electrical sockets where we can plug in, and the socket usually have its own format, or what we call as a special configuration, so that it can fit to that socket, right? So that is in its literal form, right? So it's literally. So what is it in terms of networking? So a socket, like I said before, is an interface between application and network, which used for communication between processes, right? So the upper layer protocol, how it going to communicate with the lower layer, which is the transport, the internet, and the data link communication, is via the socket. And usually in the modern operating system, so they will provide an API so that all the process of encapsulating the application data into the transport layer and internet packet is being facilitated by the operating system. So operating system will take care of the rest. So as a programmer, as a developer, we just use the socket API. So before we go deeper about what is socket, so let's see, maybe I have some a bit of, not say demonstration. So for example here, okay, so I have right. Okay, sorry. Can everyone see the text that I'm showing at the screen?
Yes, sir.
All right, all right. Thank you. So what I'm showing is in my laptop, I have a virtual machine, which in the virtual machine, I install Ubuntu server. So what I want to do is in this virtual machine, which is a separate machine from my laptop, right? So I have a server. So in particularly, I will run a web service, a web server, so that we can see the interaction between my web browser and to the web server. So here I have, so let me run my, really simple web server. Okay, so I have this really lightweight web server. So let me run my web server program. So basically the web server program is using socket programming. Later on, in more details, we will dissect how we're going to programmatically use socket API. But before we go deeper into that, so let me just demonstrate how we're going, how the web server run, right? So the web server program is being written in C program, right? In C program. So let me first run my program, which is right. So this the web server already started and is already been bind to port 8000. So why I didn't use the normal HTTP port, which is port 80 or HTTPS 443, because if we want to run to that port, that is a privileged port, which later on we will learn. So for privileged port, you need to have administrative right or root access. So for this, we will just use port 80. So it already bind to port 80. So by right, so the server is connected to my laptop via a virtual switch. So there is one virtual switch which connect my laptop to my server, right? So that's mean if I open up my Windows PC, by the way, the server IP is 5. Yep. So the server IP is 192.168.114.6, right? Right. So let's rerun our server. Okay. So for my laptop, I will try to ping my virtual machine IP. Right. So it's communicating via TCP/IP protocols. Right. So now what we will do, I will open up my web browser here. Okay, and I will put my server IP, which is 192.168.114.6. Right, and the port is 8000. So basically what it do is it will first do a HTTP request, right, based on HTTP RFC or HTTP protocol standards. So we'll do a HTTP request. So what it will do, the server will reply the HTTP request, right, from the root, and it will get the index file from the web server and return it back to the web browser, which is the HTTP client, and display it into the into my laptop. I mean, into my web browser, right? So this is the basis of what we call as web browsing. So this is what the normal web browsing do. So for example, if we want to browse a website, so what we do is when we put the domain, so basically what it will does is the web browser will request resources from a web server somewhere on the internet, and we will get back the resources and display it using the HTML and JavaScript or CSS, how it's represent the data. So what I'm showing you is really a simple one, right? So there is a client request and the server will return it back to the client. But in the background, there is a lot of things is happening actually, right? So that is what we will dissect, right? So what it does is actually when there is a communication using a TCP/IP, the web browser, which is the HTTP client, and the server, which is the HTTP server, need to call socket API so that it can use the transport and internet layer protocol so that it can encapsulate HTTP data into the network so that it can become a packet so that the server and client can exchange data between them, right? So how are we going to see the communication between the server and client? Yeah, so I have one more software that maybe we can use, which is Wireshark. So did anyone here has experience using Wireshark? Anyone?
Yes.
Yes, right. So Wireshark is basically just or some people call it a protocol analyzer, or what we call in the simplest term. So what Wireshark do is it will listen to my network interface, right? So here, like I'm telling you before this, so the communication between my virtual machine and my laptop is done via a virtual switch, a virtual adapter. So the virtual adapter name is actually virtual box host only network adapter. So basically to give you the rough idea, what it does is okay. So let me open up new whiteboard, just to give you a clear idea what is going on. Okay, so yeah, even though my laptop is the server is running on the virtual machine, everything is virtualized. So physically, it's just one physical laptop, right? So anyhow, but there is a lot of things going on in the background. So what it does is we have our server here, which is the Ubuntu server, HTTP server. Right? So, and I have my laptop, which is running on Windows 10. Right? So both of these are connected via a one what we call as virtual network here. Right? So so this virtual network, right? How this server, my virtual machine, and also my laptop connect to this virtual server, they have what they call is a virtual adapter. So the virtual adapter here and virtual adapter here. Right? So my laptop has the virtual adapter, my virtual machine has virtual adapter. And both of these are connected to this one virtual switch. Is all connected to, we connect both of these hosts into this virtual network. So where's Wireshark come in? So why we want to use Wireshark? So that we can know the background communication between the HTTP server and the Windows 10. For example, here, I will run the virtual box here. Sorry, I will run the Wireshark program here in my Windows 10. So what it will do is it will tap into the virtual adapter and it will collect all the packets which is running between this virtual adapter into and this virtual network. So we can do, we can see what happening in the background, right? So this is, this is just recap to the TCP/IP class so that we can, have some ideas basically how TCP/IP really works, right? So far, any question? So you guys still can follow me, right? Or am I going too fast?
Okay,
Right? All right. Okay, so let's so this is the virtual adapter that I'm talking about. So let's packet capture. So now there is nothing going on between the laptop and the virtual network. So let's do HTTP request back. Start. Yeah. So see now we already capture the packets, right? So let's dissect the packet. So what really going on at the background, right? So if we can see here, so let's open up these HTTP packets. So let's me open up here. So if we can see, oh, by the way, can anyone see the screen? Is it the text too small or is it okay for you?
Okay.
Okay, right? Okay. So like we have discussed before, the communication between the two hosts is based on TCP/IP standards, right? Using the TCP/IP model. So in the TCP/IP, the application layer, I mean the application that want to exchange the data is the HTTP, Hypertext Transport Protocol. So this is the application layer, right? And at the lower layer, which is the transport layer, so since HTTP protocol, it will use TCP protocol. So this is TCP, Transmission Control Protocol. So from here, we can see that the source port, which is my laptop port, and the destination port is port 8000, which the port which the server bind. See, it will bind to the port 8000. Later on, we will discuss in more details how the socket bind between the IP and the ports. But as of now, so this is how it do. And at the IP layer, at the network layer, we can see that it will use Internet Protocol version 4, right? And basically there is two Internet version, and we have version 4 and V6. And as of now, I'm using IPv4, and we can see here the source IP, which is my laptop IP. So I open up this command. If we see the virtual, yep, so this is my virtual adapter, right? So here, so 192.168.114.4. So this IP is being assigned to my interface, right? And the destination is the server IP. So the server IP is 192.168.114.6, right? So this is the server IP. See, a lot of things is going on. So every time a host is, for example, using HTTP, they want to exchange data between each other. So in terms of HTTP, what actually they are exchanging is the HTTP request and the HTTP response. So in the HTTP request, so we can see that a lot of HTML, you can see here. So this is all HTML, in the string form, right? So this is actually what going on at the background, right? So at the data line layer, so since the virtual switch is using Ethernet protocol, so this is for the data link, and this is for the frame for the whole data communication between the host and the. So this is basically what's going on, right? So at the layer 2, we have MAC address, and the IP, we have IP address. At the transport layer, we will talk about ports. And at the application layer, so there are different application layers, HTTP, FTP, so on and so forth, right? So again, I'm reiterating myself. So what socket programming do, right? So we can see that there is a lot of complexity running at the background. So we need to create program for the TCP, for the IP, for the Ethernet. So without socket API, without socket, the concept of socket, extracting all the complexity. So if you are application developer, so if you doesn't have, if the operating system doesn't provide you with the socket API, then you as a developer need to redo all of this complexity. You need to implement itself. That means you need to create your own raw socket. For example, you need to create code for TCP, for the IPs, which is really make computer really difficult to use, right? Even for the technical person such as developer. So by having socket API, the developer just only need to use the API, just call it in a function. For example, here in the web server, you can see from the C code. So as of now, this is just for your information. Next week, we will dissect in more details about how we're going to access the socket API programmatically. So anyhow, so this is how it is done. So you can see from the code. Sorry, start server here. So we use So just to create a socket, so basically a socket is just a file, right? So we just call this socket function, and we need to specify the IP address and we bind the socket to the IP address and to the ports, and we are good to go. And programmatically, we can just follow the guideline of the POSIX socket punya specification, then we are good to go. We can send and receive data between two hosts just using a socket, right? So as of now, we will not dive into details about the socket. This we will do next week, right? So yeah, so this is socket API. So far for the HTTP, so you guys still following me? Is it okay? Am I going too fast?
Okay, sir.
Right. Okay, alhamdulillah, right. So again, this is for HTTP. So maybe if since we have a lot of time, oh, by the way, we have 3 hours, yeah, for the lecture. So let's see other protocols. You name it. For example, if you are playing a game such as Minecraft, and if you are connecting to the external game server, so the communication between your PC and to the game server using TCP/IP, then this is the same, the same things that happening at the background. So let's see. I have another thing. I think in the server. Okay, so in the server, I think I also have TFTP protocol, TFTPD, which is trivial. I think TFTP. Yeah, so I have another protocols, which is TFTP, which is trivial file transfer protocol, right? So this is not FTP, right? So FTP is file transfer protocol. So I have TFTP, which is quite different from the FTP. So for TFTP, based on its standards, based on its RFC, it will use UDP instead of TCP, right? Because for TFTP, it emphasizes on speed and efficiency, not as FTP, right? So FTP is like it will have some handshake and so on and so forth. But for TFTP, it just use UDP. So let's see. I think in the server, I already run that. Yep. Let me check the status of my FTP daemon here. Yep, it is running. So let's try. So I think this server is, let's see. So what I'm doing here is I'm going to the TFTP server root file. So where if I upload and download file for my server, so this is the directory or folder that the file will be stored. So here I have one test file. Yeah, just just a normal file containing this string. So yeah, so in my window, in my laptop, I have, I think in Windows, it has built-in TFTPD server, client, TFTPD, I think. Yep, so that is. So let's try to download this file into my laptop, right? And if we done anything, so let's recapture so that we can see what is going on. So for HTTP, for the transport protocol, we are using TCP, right? So in this case, for the TFTP, we will use UDP. So we can see the UDP packet will be captured here in the Wireshark. So let's, I think -I. Let's push. I think this is my server IP. Okay, and I want to get download and the source. What is the name of the file? Test file. Yep. Test file. Right, so transfer successfully. So the file is just, the small file, very small file. So let can see, did we capture any? Yep, so here the TFTP packets already been captured by the Wireshark. So if we dissect the data, let's see, below UDP string. See, so this is the file that already captured. If we can see here, instead of using TCP, we are using UDP. Later on in this lecture, we will recap back what is TCP and UDP. So anyhow, instead of using TCP, now it is been using UDP. So the port is this is the source port and this is the destination port, and this is the actual data which has already been captured. Right. So when I open up my PC here, I think the data is being downloaded into this directory. Let's see. Test file. Yeah, so the file is here, test file. See, I think the directory is CUZ. See, yeah, so this is the file which already been downloaded. I think, yeah. Okay, so this is TFTP. We are transferring file, so we can see that instead of TCP, we are using UDP. So again, like I'm telling you before, even though it seems like very simple, right? Because all the complexity already been abstract by the developer, which are writing the program, and most importantly, the complexity of the TCP of the IP already been abstracted by the operating system. So operating system will handle it, and it just provide an interface, which is the socket, to the developer. So the developer just use the function, then it can use the socket, right? So, but as a networking student, so we need to use this socket so that we can create our own network protocols, and we can, understand, the fundamentally how communication works in the modern computer system, right? So, yeah, again, back to our lecture. Right, so socket, again, interface between application and network, which used for communication between processes. Yep, because when we are creating a program, when we execute the program, it will be loaded into the memory, then the program will become a process. So now we can do communication between two processes at two different hosts using a socket, and a socket is an abstraction for file for network communication, just as a file. So basically in Unix-based operating system, right? Everything is a file, right? So even a socket. So when we create a socket, so basically from the operating system perspective, a socket is just a file where there is a file descriptor, which the file descriptor will point, give a information about the file, right? So later on we will discuss about that. And socket are used for inter-process communication. So this is what been done, what I have already shown you before this, using HTTP and TFTP protocol. So how does sockets work? So the application create a socket, right? So application first will create a socket. Then after that, since they are using the socket, the programmer, the developer can choose either they want to use which style of communication, right? So they can either choose reliable or best effort, or connection oriented or connectionless. So if they decide if they want to create application, for example, for what we call as transaction, for important transaction, for example, for banking, for example, right? So for example, if we are creating application where these two hosts will communicate a transaction, for example, in financial transaction, so the application, the protocol that you are going to use, of course, you want to choose reliable type of style of communication, because for transaction, right? So when the packet or the data being exchanged to the internet, we cannot guarantee that our ISP or the network able to send the data as is, because in the internet sometimes there will be a fiber cut, there will be some issue within the networking equipment. So what will happen is sometimes our telecommunication provider or ISP will drop the packet, right? So how are we going to ensure that the data has successfully been transferred from the host A to host B, right? So and the data arrive in the same order, right? So that is what we call as reliable style of communication. So if we want to have reliable style of communication, we need to use TCP as its transport protocol. Because if we are using TCP, that's mean if let's say the TCP detects that the data, the packet is lost, so one of the data is lost, what it will do is it will do retransmission. So TCP will resend back, it will request back from the server, and server will resend back the data. And once the data is arrived at the client need to provide an acknowledgement to the server saying that now I'm acknowledging that the data I have successfully receive the data, right? So that is for reliable. But if you want to to design an application or design a protocol which you really doesn't really cares about the reliability, but what you want to have is efficiency and fast. That's mean, for example, for real-time communication, for example, if you want to do Zoom, or you want to do online meeting application, for example Zoom or WebEx or Google Meet, right? Or for example, if you want to streaming applications such as Netflix or YouTube, right? If you really doesn't care about if whether the data is sent or not, but what you want to emphasize it on the speed and efficiency, then you can use UDP, which is it will based on best effort style of communication. So why you doesn't in this kind of style of communication, why reliability is not an issue? Because in real-time communication, so if we are using TCP, where in TCP, as you already learned before this, it will have three-way handshake, right? So every time a data is sent, there will be an acknowledgement and so on and so forth. So it takes a lot of overhead. So if you want to have real-time communication, such as online meeting like we are using in this class, if the latency is too high, right? So if you need to do this acknowledgement, this handshake and everything, sometimes the data, it will become too late, then the jitter will increase. So what the quality of the video of the real-time communication, usually we see that the video will be started, right? So sometimes sangkut, you can see that the video is sometimes when people are talking, then the other side just received, then we can see that the video is really started, right? So that's why if we can for this kind of communication, for example WebEx, usually people will use UDP. So depends. So both TCP and UDP has its own advantages and disadvantages. And also connection oriented, which is TCP, where in TCP, when we begin the communication, right? So basically there is a three-way handshake, right? Where it will first establish some virtual tunnel between the server and the client, or the UDP, which is connectionless. Okay, so as a developer, if we want to use the socket, we need to specify either we are going to use TCP or UDP. And once the application already set up the socket and already bind the application the socket to the certain port, then we can pass the data over the socket. So let's UDP or TCP handle the communication, right? So what if we can see from the code here, again, so this is just for to strengthen my my argument. So anyhow, next week we will deep dive regarding the coding. So I have some simple code here. right? So this is using socket. So from here, once you know, the socket already been established, I already bind it to the certain port using the bind function. After all of that has been taken care of, so we can see that I can, you know, just simply use write and receive just as a file. For example, you know, we can just, you know, regards the socket just as a file. So if we want to send data, so we just write the file into our socket. And if we want to retrieve back the data, we just read back from the socket, right? So once the socket has been, you know, has been configured, now we can write and read data from our socket, as easy as is. But since we are creating our own protocols, so we need to create our own process, our own algorithm. That's mean, for example, if our client want to, for example, based on our protocol design, for example, if you want to create your own protocol, right? So based on our protocol design, so we can see that, yeah, when the client want to first um, um, uh, request the service, then it will need to write requesting something. Then if the server get it, then you know, what is the reply and so on and so forth. But to facilitate that communication, we can just simply use socket, right? So we are, as a developer, we are the one that define how the process of our application, how our application exchange the data. But for the TCP, for the IP, everything has been taken care of by the socket. So that is what we want when we use socket, right? Okay. Anyhow, do you guys have any question? So did I go too fast or too slow? Huh. Still with me?
Yes, sir.
All right. Okay. Alhamdulillah. So sikit lagi, you know, before we have 5-minute break. Yeah, so most of the inter-process communication follow a client-server model where client and server are two separate process in itself, and server and client exchange a message over the network through a common socket API, which we will discuss next week, where each of these, you know, the socket API for the OS, right? For the socket API, there is different function that we can call so that we can use the socket API, which we will learn next week, right? Inshallah. Right, so primary socket function. So most of the socket, we can open the socket, we can close the socket. So this is important. So when later on we do some development using the socket, one of the you know, common mistake that I see from my student is when they finish their program, they didn't close the socket. So what it does is, maybe it seems like trivial, right? But if you didn't close your socket first, what will happen is, if you want to reuse the same port, for example, if your program is using port 8080, right? So if the previous process using the same port 8080, right? If you doesn't release the resources, that means when you want to rerun the process, it will become a conflict, you know, because from the operating system point of view, two processes are trying to use the same ports. Then we can see, you know, errors. So we can see that, you know, both process are trying to use the same socket. So there will be a binding error occurs, right? So we need to close, and we can read and write. So once the socket already been configured, like I said before, if you want to communicate the data, regardless of the distance, yeah, regardless of the distance, because the TCP/IP nowadays, right? Because it span globally. So as long as you have a public IP address, right? Even though maybe you are in Indonesia and another server in Malaysia, for example, irregardless, if for example, if Indonesia have Telecom Indonesia, for example, and in Malaysia we have Telecom Malaysia. So if these two ISP or these two telecommunication network has peering with each other, maybe they can, you know, exchange data with each other. So irregardless of the distance, so we can, you know, send data between these two hosts, right? And the rest is being taken care of by the TCP/IP layer, right? And next is the control. So this is a function. So for example, later on we will learn about advanced socket function, where the function we can set certain parameters. For example, if we want to enable keep alive features is where, if for example, based on the socket, right? So if the socket detects that maybe the server or the client is not functioning, maybe what we call in programming term timeout. So maybe if the server is not responsive, then we can say that, okay, so this server is not responsive, then we can shut down the pod. That is for the control operation. And later on, we will learn what we call as advanced socket function. Right. Is it okay if we take a break, or you guys want to continue? Or break 5 minutes?
Break 5 minutes, sir.
Break 5 minutes, right? So I think everyone already been overloaded. So yeah, let's take 5 minutes breaks. But before that, let's do some fun quiz, so that I can see the level of understanding. So I have prepared a Kahoot quiz. So let's do together before our break. Okay. Share. Okay, can anyone see the Kahoot screen?
Yes.
All right, so I want everyone, right? So please, open up your web browser, open www.kahoot.it, and put the game pin so we can play together, right? Kim Jong-ko. Oh. Ni ada minat Korea ni kot Kim Jong-ko tu bukan yang kita. So yeah, I give 1 minute. So before we begin, Elden Ring. So nampaknya ada orang main Elden Ring Dah lepas belum? Susah betul. Ada siapa apa yang main Elden Ring tu dah habis ke belum? Saya tak, sampai sekarang tak habis-habis. Sumpah susah.
Dah habis lah.
Habis dah.
Habis dah.
Alhamdulillah.
Ya Allah. Nanti boleh saya minta apa ni tak? Ada buat walkthrough tak? Nak tengok boleh. Okay. Okay lah kot. Dah ramai. Jom kita start. Yeah. Okay. Introduction to socket programming. What is socket? Okay, yes. So I think majority is true. I mean, get the correct answer, which is an interface between application and network, like I'm saying before, right? So we have upper layer application, and if you want to use the lower layer services such as transport, IP, and data link, then we just use socket, right? So that is socket. Next, okay. Next, so true or false? Socket is an abstraction like memory. Okay, so no. So the question, even though it did abstract the complexity of the lower layer services, but in more accurate terms, so a socket is an abstraction like a file, not a memory. So socket is an abstraction of, more accurate is like a file, right? So next, okay, which of following is a not socket communication style? Okay, oh, I think not all of you get it right. So the false answer is sequential. So we have reliable, which is TCP, best effort, we have UDP, and connectionless, which is also UDP. So sequential, not so much. So there is no sequential type of communication as of now, right? So maybe later on, one of you guys, create your own, transport protocol, then there is different altogether, right? So let's see. Okay, true or false? Most of the IPC using socket follow server client model. Yes, true. It will follow server and client model. Most of the communication on the internet nowadays are following server and client model, but it doesn't mean that there is no other type of model. So sometimes, for example, if you guys are using BitTorrent protocol, or what we call as peer-to-peer protocol, right? So for that is basically using peer-to-peer model. So that means there is no server, there is no client. Everyone is a client, everyone is a server, right? In the peer-to-peer P2P punya model, right? But majority of it, for example, if we are web browsing, downloading a file using FTP, if we are, for example, watching YouTube, right? Basically, YouTube is using the WebSocket from the HTTP. It based on server and client model. Okay. Next, okay, so last but not least, put data. So which statement it refers? Okay, so this actually refers to write, right? So we are putting data from application memory and send it over the socket. So this is referring to the write function in the socket, right? So this is one of the function that socket must able to give, must able to provide. We can put data into the socket and it will send it to the other peers, other hosts, right? So let's see who has the highest mark. Azizi, right? Okay. Okay, the highest mark is high. So yeah, high back to you. So okay, so I think that's conclude for our first before we take our break. So we take a break around 5 to 8 minutes. And we can start back our lecture, right? Okay. So thank you for your commitment. So I see you guys back in a bit. Oh, before that, let me share with you the attendance links. So I hope that everyone can fill up your attendance. So your attendance, I will put it at the WebEx chat box. So basically, it is a Google form. So please click on the Google form. So please, if you are from UGM or from UiTM, so please fill up the attendance so that Dr. Bambang and me can, take your attendance from there. Right. So thank you. I will see you guys in a bit. We will continue on the second part of our lecture. So, okay, thank you. Okay. So can we begin back our lesson?
Can, sir.
All right. So let's continue. So sikit lagi. Okay. Where were we? All right. So as been told before, oh, by the way, the socket that we are learning in this class is based on Unix socket, or the socket programming that we will implement in Linux-based operating system or in Unix-based operating system. For Windows, there is also a similar implementation of socket, but the name is not a Unix socket. So the name is basically WinSock, right? So in Windows, the socket library name is WinSock. So if you guys want, maybe later on want to explore it yourself, there is WinSock. So WinSock 32, basically known in Windows. So how it's been implemented is basically the same way, right? Because regardless of if you are using Linux or you are using Windows, if both are using TCP/IP protocols, it should have the same implementation, the same process that we're going to use, right? So in Unix or Linux-based operating system, everything is a file, right? So everything is a file, including a socket. So for example, if we just created a socket, so it will be treated as a file, right? So if you are treated by as a file, so that's mean that you will be assigned a file descriptor. So what is file descriptor? So it's simply an integer associated with an open file, right? So there are three standard POSIX file descriptor which every process should expect to have. We have 0, which is the standard input. For example, if we want to for the program user to provide input to our variables, so the input file, right? So it will be given 0 as its file descriptor. And if it is for output, if we want to print out into terminal, or if we want to print out into file, so it will have 1 as its integer value for its file descriptor, and it is for the standard output. And 2 if it is for standard error. So for example, if there is an exception, so any error that we want to print out, we want to catch, then there is a file for that. So basically the value, integer value will be given is 2. So is there more? Yes. So by default, all of the Unix file, all of the Unix or Linux process will have these three value, 0, 1, and 2. Because in any process, yes, we need to gather an input and we need to produce an output, and we will have, maybe we have some error handling mechanism. So that's why we have standard error. But if, for example, we are using a socket, or if we are saving our data into a file which we save into our hard disk, then we will have more than 3. We will have more than 3 file descriptor. So let's see, for example, right? So you can see here, okay, so in Unix, usually we will have a file descriptor tables. Every process will have its own table, right? So we can map it. So basically this file is referring to what? So for example here, let's see this first. So can anyone see the figure that I'm showing you right now?
Yes, sir.
Yes, sir.
For examples, right? So for example, if we declare a socket, for example, then the socket will be given a value. For example, usually it will be given either 3, 4, and so on and so forth. it will be it will not be given 0, 1, 2, 0, 1, 2 because these three by default will be created. If we like it or not, it will be created. So if let's say we add another socket, which is just another file from the operating system perspective, so usually we will be given either 3, 4, and so on and so forth. For example, here from the table we can see that for example, number 1. So it refers to this write option. So this file can do write operation, and this refers to this home. So this file is based on this path, for example. So that is a table which describing. So same as socket, right? So yeah, let's see. For example, let me open up my Linux machine. Okay, so anyone can see my machine, my terminal?
Yes, sir.
All right. Okay, Alhamdulillah. So first, let's I make some simple program here. All right. I think here, okay, simple socket programming. So anyhow, again, we will discuss in more details programmatically next week. But what I want to show you here is this. So here is where the portion where we create or we declare or we create a new socket, right? So the socket API, the socket function, when we call the function, it will return a value, which is the file descriptor value. So the value will be stored in this variable sockfd, right? So here I will print out the value of the socket descriptor. So usually the value is in integer value, integer type. So here it will print out to the terminal, so we can know our socket value, our socket descriptor value. So let's see. So let me compile this program. Right. So let's run it. Okay. From the terminal, we can see that the socket descriptor value is 3. Right. So why it's not given 0, 1, 2, 3? So why it's not given 0, 1, 2, 3? Anyone can guess? Because like I said before, 0, 1, 2, 3 already been given for the standard input, for the standard output, for standard error file, which will be doing all these things. For socket, it will be given other than this value, which is 3. For example, if I create another process within the program, so let's okay, so let's create another one. So let's copy this. Okay, let's name this sockfd2. Okay, so that we do not overlap with this, and we call another socket function. So we create another socket. So it will be address family IPv4, INET, and also TCP. So okay, so let's create the one, and we will print out this value. Okay, so let's print out for the socket FD number 2. All right, so FD number 2. Okay, and also I think I need to declare this variable. So in C programming, we need to declare all variable, right? So I think I just put the statement here. So fd2. Okay, so I saving this file. So let me recompile my file. Okay, so no issue, no syntax issue. So let's run it. Okay, so now you can see that, yeah, so for the first socket, it will be given file descriptor number 3, and for socket number 2, it will be given number 4. You see? So this is, so the file descriptor is only apply to the single process, right? Only for that single process. So for example, if we have another process also using a socket, it will also have 1, 2, 3, 4 socket descriptor, but it will be only unique for that process because operating system will store each process file descriptor table. So each process will have its own file descriptor table, right? So based on the table, we can refer. So for example, 3 refer to socket number 1, 4 socket number 2, so on and so forth. And it's not limited just only to socket. So if, for example, you are opening a file, for example, and the file is within your persistent storage, for example, your hard disk, then it will also have its own file descriptor. So that is my point. Any question? Still can follow me?
So descriptor 012 tu for local files. Macam tu.
Dia bukan not local file. So dia lebih kepada, dia macam default tau. Setiap proses ni kan dalam unit ada banyak proses kan. So the default dia nak tak nak kalau kita guna ke tak, memang dia akan ada 0123. 012. Dia akan ada dia punya standard input, output, error. Memang dalam Unix kalau kita buat je proses memang ada 3 benda ni lah. Macam itulah.
Okay.
Dan,
Thank you, sir.
Thank you yang tanya soalan. So very good question. So macam again lah, macam dalam slide ni terangkan. So based on the explanation. So for the 0 untuk standard input, output, error dan seterusnya. Contoh macam 3 nanti itu untuk socket lah. Seterusnya lah based on apa yang kita guna. Alright. Okay, so ini dia punya macam somehow dia punya apa ni, dia punya kalau contohlah kita nak visualizekan dia kan. So contoh kita kat sini ada program tu, kita punya proses tu. Kalau user tekan keyboard, contoh user macam type, so for example your program, please enter your name, kan? So contoh user click on the keyboard, provide the process with the name which been requested, and it will use 0 standard input. So if, for example, we want to display it into the screen, into the terminal like this, so it will use standard output, this one, number 1. And for example, if the program has runtime error, for example, if we are doing programming, always when our program has a runtime error, for example, if we want to access memory location which is not available, so it will create an exception or runtime error. So if the process want to display the error, it will use std error, standard error, and it will have file descriptor value of 2. So if we are using socket, then we have 3, 4, so on and so forth, right? Because socket is not by default created by any process. Okay, only these 3. All right. Okay, so layered model of networking. So I think I already explained it to you guys before this. So we are how the modern networking works nowadays. Everything is based on this layered model of networking, which we often call as TCP/IP. So we have the application layer at the top, and if it wants to use the service of the lower layer services, the lower layer protocol, then we can use socket. So socket is the mediator, is the interface between the application and the other layer in the TCP/IP model, right? So maybe I have question for the class. Why we need to have this layered model? So kenapa kita buat dia layer by layer? Kenapa kita tak kenapa tiba-tiba engineer, network engineer ataupun system engineer dia decide kenapa, why we need this different layer, application layer, transport layer? Why we just use single layer so that we do things like that, right? Instead of we put it layer by layer. So anyone care to guess why?
Systematic.
Yes. So again, we as human, we want things to be systematic. Again, yes, really, I like the term systematic, right? So that we can separate it. So for example, if we make it layer like this, right? Really, we structure it more systematic. And for example, if you are a programmer, a developer, wanting to create an application layer protocol, so you only concern on this upper layer. You really doesn't need to care about TCP, IP, all the networking stuff, right? So you only focus on that so that you doesn't have all of this complexity. You only focus on your application. But if you are operating system developer, for example, if you want to implement at your OS the transport layer, the TCP, the UDP, then you only focus on developing the transport layer. You maybe, for example, maybe if I can share with you, right? So so far, maybe the most common used transport layer is only TCP and UDP. But did you guys know that big companies such as Google, Facebook, all of these big companies, they think that uh, TCP and UDP is not enough by them, for them, because for them, they said that TCP and UDP have some limitation that need to overcome. So that's why some of their developers are developing new kind of transport layer protocol. So one of the project which is known, which is Quick. If you not the QUIC protocol. So Quick protocol is basically not an application layer, but this is for transport layer. So this basically be introduced by engineer by Google, Jim Roskine, and based on the limitation he saw from TCP and UDP, so he announced that yeah, I'm working on this Quick protocol where it's get the limitation of TCP and UDP. So what this protocol claims that it able to solve. So it will have the connection-oriented protocol that we love so much with TCP, the reliability of the TCP, but in the same time, it will also have the quick and efficiency of UDP. So it bridges the two together, right? So yes, so that's why. So if we, if we put the model in the layered form, right? So that one engineer can focus on one part, so another engineer can focus on another part. So that, it's become really systematic if we, do the TCP/IP in the layered punya, from the layered punya perspective. So we can see. So UDP, maybe later on you guys can explore, right? And if I'm not mistaken, Quick protocol already been implemented in the new HTTP3 protocol. So now most of our communication are using HTTP 2.2, if I'm not mistaken. But there is a newer HTTP application protocol, which is HTTP3, and the transport layer, it will use Quick instead of the normal TCP. See, this is the new standard, right? So maybe in degree level, you are not, you're not touching this stuff because you are just learning the fundamentals such as TCP, UDP. But if later on, if you want to do your postgraduate study, for example, if you want to do your master study or your PhD level, so this is what you're going to see. You are solving the problem, and you need to propose a solution to the problem by inventing your own, by designing your own protocol like this, right? So anyhow, this is for your FYI lah, just for your information. Okay. There is a lot of library already we can use to use Quick, right? How they implement Quick protocol. So anyhow, back to our lecture. Okay, and for example, if you are network engineer, right? For example, if you are concerned more about IP address, you are concerning more on routers, switches, how you're going to interconnect everything, then you doesn't really need to develop or create your own solution for TCP for the upper layer protocol. You doesn't need to create a program for TCP, UDP. Let's the engineer for other layer take care of your problem. So as a network engineer at the network layer, you only focus more on improving your network, improving your IP protocols. So that's why we have layered model of networking. Okay, is it clear? Anything that I need to re-explain?
Clear, sir.
All right. Okay, so we proceed. Okay, so now, so for socket programming element, so this is the abstraction. So from the figure here, we can see that we have application, so which is UR, which later on in assignment, you will do your own network application. You will create your own network application, and you will use the services of the lower layer protocol, such as TCP, UDP, IP. And how you're going to use that services is via a socket. So socket is this, the one that bridge the gap, right? So if you want to use, first you need to specify the port that you are going to use, right? So the port, if using TCP/IP, the port number is 2 to the power of 16. So because so 2 to the power of 16. So we have 65. Ya, saya jarang guna window calculator ni. So let's kita Google dia lah. So 2 power of 16. Okay, so we have 655 ports, ranging of port. So kalau macam we can see that here. Kalau kita tengok okay, so we can see here that for TCP and UDP, we can choose which port that we are going to use. But of course, since internet is shared by billions of people on the world right now, as of now, so for port ranging from 0 to 1023, this is what we call as well-known port, which is used by well-known protocol over the internet. For example, if HTTP already occupied, sorry, HTTPS already occupied 443, and it can use both TCP and UDP. And we have WHOIS, so on and so forth. We have FTP, we have datetime, we have SNMP. So all of this is known as well-known port. But if we are going upper than that, this is what we call as registered port. So usually a company, right? So for example, if they create their own software solution, for example, a company like IBM or HP or all of these big tech company, right? So sometimes they say that, yep, I want to create my own network protocol. So yep, my developer come up with this new protocol. So I think I want to register the port. So what they can do is they can register it by sending their request to INA. So this is the Internet Assigned Number Authority, where these are the governing body of the internet. I say that, yep. So since you are using this port, so nobody else can claim that globally can use that port. But for for the development, for the experimentation, so no one can stop us from using this port. But if we want to deploy it to the public, we cannot use the same thing, because for this port is already known to use OpenVPN. For example, 1194 is for OpenVPN. You can see that a lot of registered port, and all of this is being registered, most of it by the company. For example, if we see here, such as Civilization 4 game, it will use, you know, for the game to connect to the game server. Usually it will use port 2056, for example here. So this is registered port, right? For example, for Warzone, Apple, Apache, so you know, big tech company, you know, registered their port, right, officially. And for example, like, you know, that Diablo game, Microsoft ends, a lot of application here. So beyond that, we also have what we call as dynamic, private, or ephemeral port. So this is unregistered port. So in short, everyone can use, right? Even in the public, if you want to deploy it widely over the internet. If let's say you are saying that, yeah, my application will use port 49999, no one can stop you saying that, no, that is for my protocol, because everyone can just, you know, this is not a registered port, right? So you can use it, right? So if in your assignment, if you want to create your own protocol, you can use this port range. Or since this assignment only for this class only, so what's stopping you from just using, you know, well-known port? Go ahead, just use it. But just like I has mentioned before, if you want to use port from port 0 to port 1023, usually in Linux and Windows, since this is well known or registered port, usually you need admin right or admin access, root access to use that port, right? To reserve the resource to use that port. Okay, so that is a port. Any question? Clear?
Yes, sir.
Right. Alhamdulillah. So next. So for these socket program elements, so we have the host, which is the interface. So usually at the host, I mean the host is you know, the server will have its interface, and each interface will be assigned with the IP address. So each host will be given an IP address. The protocol, the transport protocol that we're going to use, if we want to have connection-oriented or reliable style of communication, we will use TCP. If we want to have best effort or connectionless style of communication, we can use UDP, and we also need to bind it to the port and the IP address. So later on we'll see. Next week we will see how it bind it. We can bind it when we using socket programming in C, in C programming, in C language. Okay, so one of the element is host. So what is host? Hosts are identified by addresses, and for IP, this is called by IP address. So if we are using IP protocol, internet protocol, so by design, all of the hosts connected to the internet should have its own unique IP address. For example, here, my PC, so my PC has been assigned with IP address, but since you know, IPv4 nowadays has limited number of IP available to the public. So now, since we are running out of address space, right? So for IPv4 nowadays, we have what we call as private IP and public IP. So public IP is what is unique on the global internet, and private is what used in the internal network. So usually, if the internet internal host, internal network want to reach the internet, we will need to do network address translation, so that from the private IP will be translated back into the public IP, so that we can save on IP address. Because nowadays we have a global shortage of IPv4 address. But if we are using IPv6 address, that is not the case, because IP address, there is a lot, abundance of IPv4 address, and we doesn't need to do the network address translation. But in this case, you see from my PC here, I'm connected to my home internet via the Wi-Fi. So here you can see that for IPv4 address, I have this. My private IP 192.168.0.196. So this only unique for my home network, right? So if I want to access public internet, if I want to reach people, maybe living in Indonesia, so I need to have public address. So my ISP will assign my broadband services at my home with one public IP. So if I open up my web browser, if I use this, what is my public IP? So this is my public. Tak nampak. Yeah, so this is my public IP. You see, so this is unique. So at this moment, at this moment, this public IP is unique. So no one else is using this public IP, and this is unique for my home network. So when it reach my home network, the router will do network address translation, and it will be translated back into my private IP here, right? But for IPv6, right? So my home, I have IPv6, right? So for IPv6, that is totally different case. For IPv6, we have abundance. So every host on the network is unique. So there is no network address translation involved. So for example, here we can see that my IPv6 address is 2001E6 something in hexa. Okay, so if we see here, my public IP address is public, you see, 1002. So this is direct end-to-end communication. If right now, in this world, the only person that are using the IPv6 address is my PC. This is unique all over the world right now. For public IP, only unique for my network. And when inside the network, it will be shared by multiple hosts inside my network. Okay, clear? Okay, sekarang ni kalau kamu ping 2001 boleh ping lah IPv6 ni kalau kamu punya, if your house has IPv6, then you can ping the IP and you can straight away send packet to my computer, right? Okay, so usually in IPv4, it will have 32-bit of addresses, and usually it's been represented in decimal notation like this. We have four octet, maksudnya 8 bit, 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 8 bit. Total we have 32 bit of address. And this is in the hexa representation, but normally we doesn't use this form. So usually we will use either binary and decimal notation like this for IPv4. But for IPv6, normally we will represent the value not in decimal but in hexa, since IPv4 IPv6 bit is 1 to 8 bit, so it's very long. So if we are representing in decimal, then the value will be very large. So that's why, to make it easier to read, so that's why it's been represented in hexa. So this is in hexa form. Okay, still following me? Okay, any question?
Okay, sir.
Okay, sir.
Okay, alhamdulillah. So next. Aish, sakit tekak ni, tiba teringat cincau, Bandung cincau ni. So bear with me sikit again. Okay, next is about the protocol. So again, if we are using socket, then we can specify that if we want to have reliable protocol, then we can use TCP. If we want to have unreliable style of communication, we will use UDP. Depending on your application design, you can use either TCP or UDP. And for the ports, so port is like a virtual destination point on your host, so that it can allow multiple simultaneous traffic from your computer. Okay. Anyone here can guess what will happen if someone when they think about TCP/IP protocol, they doesn't put the transport layer. Maybe they left out the transport layer. So maksudnya dia orang cakap okay, tak payah nak pakai transport layer. We only will use application, network and data link layer. So we doesn't need transport layer. So I want to ask all of you, what do you think the implication of not having a transport layer, not having a port? So what will happen? Anyone can guess? Anyone?
Putusan
Khusus. Macam mana?
tak dapat apa get lost.
Apa packet? Dia punya idea tu saya dah faham. So dia sebenarnya kalau kita tak ada konsep port ni, kita tak boleh nak ada, dia punya point kat sini, kita tak boleh nak ada simultaneous communication. That mean, contoh kalau kita tak ada konsep port, kita punya komputer ni, for example kan, kalau kita komputer ni kan, kita buka web browser, lepas tu kita buka email, lepas tu kita buka Zoom, lepas tu kita buka apa lagi? Saya buka kat sini WhatsApp. So satu komputer tu kita nak buka macam-macam kan. Kalau kita tak ada konsep port ni untuk buat virtual endpoint dekat kita punya host, kalau kita tengah browse internet, contoh kita gunakan port 80 kan untuk browse internet ni kan. Kita browsing, tiba-tiba ada orang nak hantar message menggunakan WhatsApp. So WhatsApp tak boleh, dia kena tunggu sampai kita tutup web browser baru kita boleh guna WhatsApp. Betul, tiba-tiba kalau kita nak guna email, kita tak boleh nak browse internet. Is it convenient? Not, right? So that is the concept of port. So by having the port, the host will be able to have simultaneous communication. So tu implication dia kalau kita tak ada port. So sama juga macam server. Kalau kita tak ada konsep port tu, dekat server ni, kalau kita this for example here dia running dia run server tu gunakan port 444. So kalau kita nak run servis lain, dia nak serve servis lain tak boleh. Tu server ni hanya untuk 444 je, tak boleh. Payah kan? So that's why by having a port, a server can serve multiple services. Dia boleh buat HTTP, dia boleh buat FTP. Kan? Kalau kita ada banyak resources, satu server tu boleh serve multiple service. Dan untuk komputer, untuk end user macam laptop saya ni boleh at the same time boleh browse internet, boleh buka email, boleh file tanpa semua benda lah. Sometimes kalau saya tengok saya punya adik dia guna my brother dia guna the laptop. Sometimes you can see that dia main game contoh dia main game Minecraft. Sometimes Minecraft betul kita selalunya kalau kita main game online selalunya kita ada apa? Macam mana kita communicate dengan kawan kita? Kalau kita main online. Gamer tahu ni.
Discord.
Apa tu? Yes, Discord. Discord kan ada protokol sendiri. So the same time kita main PUBG ke ataupun kita main Minecraft, we can use Discord bercakap. Kita cakap over IP guna Discord. At the same time game tu pula main. Betul, in the same time ada pula email. Tiba-tiba ada pula WhatsApp. Tulis kat situ Sir Azizi assignment 1 tolong bagi protokol. Kan? So dia bagi simultaneous communication lah. So there is port. Ni saya dah terangkan dah. So contoh ports on Linux. So on Linux system, the port number is limited to the power of 16. Macam saya tunjukkan tadi. So it can range from 65535. So from 1 up until 65535. But of course, like I'm saying, the lower level, lower port number is also has been reserved for well-known ports such as HTTP port 80, HTTPS 443. 25 for SMTP, or 23 for Telnet, so on and so forth. Non-protocol ni dia akan gunakan lower layer. Then for the upper layer, we have registered and unregistered port, right? Okay, this is examples. If we bind it together, then we can say that, yeah, so I will want to connect to the service, to the web service at this IP address. So this is the server IP address using port 80. So that's why when, example, let me try to rerun back my web server. Okay, so sekarang kita dah bind dekat port 80, 8000. So IP saya apa tadi ya? Alamak, saya lupa. 192.168.40. Sorry, 114. 114.6 kan? Nampak? Kita gabungkan sekali dengan port dia. Nampak? So this is referring to the socket, referring to that process. Kita nak ni, nampak? Kita ada gabungkan IP dia dan juga dia punya port. Okay? Soalan cepu mas. Kalau sekarang ni kamu ada browser, kamu letak IP di kat kamu punya web browser, kamu rasa kamu boleh access ke saya punya server sekarang ni? Do you think so?
No.
Kan pasal ini
No.
adalah private IP. Dia hanya it's only unique in my local address. Kalau saya nak benda tu, kamu boleh buka saya punya server tu. Kamu boleh right now go into my server. So saya kena ada public IP kan? So I have one public IP now. Saya dah hostkan dekat cloud. So let me open up my okay, saya ada satu VM Okay, so sekarang ni VM saya adalah 14.102.146. Ni adalah public IP range. So saya dah hostkan saya punya server ni dekat dalam data center, dekat data center punya provider. So sekarang ni kalau saya buka ni, so this is unique all over the world. So only me as of now can use this. So this is my my project. So kalau sekarang ni kamu buka kamu punya komputer web browser, cuba kamu letak sekarang ni IP ni. 14.102.146.22. Keluar apa? Keluar tak? Sama macam saya keluar ni. Cuba try. Tak try. Keluar tak?
Sama.
Sama, right? So this is public. So sekarang ni kita ada public IP dan kamu akan access dia menggunakan port 443 tau. Sebenarnya ni adalah HTTP. So this is 443. Okay, so this is HTTPS. Kalau kita tengok dekat server saya ni, kalau saya tengok command, saya gunakan command net start. So let me open up my okay, so kalau saya gunakan command net start, saya punya web server tu saya gunakan Nginx lah. So kalau kita tengok kat sini 443 so nampak kat sini IP 443 saya dah bind dekat port 443. Nampak port 443 HTTPS. Nampak tak saya tengok kat sini ada ramai orang try IP ni. So mungkin tadi you guys tengah try kan? So nampak ini mungkin IP salah satu public IP kamu, nampak? Okay. So I akan monitor lah siapa yang access saya punya server. Okay. So this is public IP lah. So tapi anyhow since public IP ni dia limited, so kita kena host dia dekat provider, kita kena sewa lah. Kita kena sewa, so somehow we need to pay hosting service lah. So now this is how it works lah. So later on, bila kamu buat your own network protocol, kalau kamu nak benda tu can be accessed globally by anyone, tak kisah from Indonesia, from Singapore, from Malaysia, so you need to have public IP lah. Or unless kalau tak nak tu tak apa, boleh gunalah IPv6 kan. Macam server saya ni pun ada juga IPv6. Contoh. IPv6 saya tak perlu nak sewa pun, dia memang been provided. So kalau contoh saya letakkan IPv6 saya ni kan, kat sini keluar juga benda sama. Tak keluar. Malunya. Sekejap sepatutnya keluar lah. Dah. Oh, okay. My ni, saya punya IPv6 dekat PC saya tak jalan. Saya tak jalan. Sorry. Saya kena restart router buat. Saya IPv6 saya tak jalan. Boleh. Okay, so tapi dia tak nampak, dia tak map dekat IPv6. Tak jalan lah. Tak jalan, saya punya IPv6 tak jalan. Nampak? Saya open DNS, tak ada IPv6. Kalau saya kalau saya ping server saya nampak dia boleh reachable je, dia IPv6 dia, cuma not sure kenapa dia tak jalan dekat saya punya browser. Is it DNS problem? IPv6. Tak apa, nanti saya check lah. Tapi anyhow, kalau kita IPv6 tak perlu ada public apa. Dia dah memang public, dia tak ada private ni So tu point dia. So regardless. Okay, again, for example, so ni lah kalau kita nak gunakan socket ni, kita dah bind. Okay, ni dah terangkan kalau tanpa ports dia akan jadikan communication tu tak simultaneous, dia akan jadi sangat susah Dia tak boleh simultaneous communication. So this is example of port number saya dah tunjukkan tadi. Kita ada well known port, registered port. For example, kalau 22 SSH, 23 Telnet, 25 SMTP. Kita ada POP3 110. Okay. Okay, so contoh kalau kita nak define endpoint. So sekarang ni kalau kita nak define endpoint of the socket, cara kita nak address dia adalah contoh kalau kita punya socket tu menggunakan TCP, so kita akan pilih TCP, IP address dia, IP address yang kita gunakan dekat server dan juga dia punya port. So this is the how we going to define the endpoint if we are using the socket. Macam ni Kita menggunakan TCP, address, host dan juga port. Okay, ni contohlah how the interaction works. Application dia menggunakan port 4097 dan menggunakan TCP. Ini IP yang dia bind dan kemudiannya dia akan dekat dia punya client for example, ini IP dia. So macam inilah. This is how they communicate with each other Okay. Okay, so most of the network communication on the internet using client and server model. Oh, sebelum tu do you guys have any questions so far? Still get it? Am I going too fast?
Okay, sir.
Right, okay, alhamdulillah. So no problem, don't worry. Yes, this is very technical, but next week we will see how we going to use this when we going to develop a program So kita akan guna function, kita akan guna tu. So itu mungkin lagi jelas lah kamu boleh nampak So sekarang ni kita belajar dia punya teori. The fundamental about the socket. Okay. Okay, so most of the communication on the internet follow client and server models, like I'm saying before. Majority of it, if we are using HTTP or we are using FTP, most of it will be client and server model, where there will be a HTTP server somewhere. So contoh macam saya buka saya punya project punya website ni tadi. So basically yang jadi HTTP server adalah server saya yang saya hostkan dekat cloud ni. Yang saya hostkan dekat data center saya dah tutup tadi. Ni lah. So server saya ni, saya host dekat data center. So data center tu bagi saya public IP, so dia host lah. So dia akan hostkan saya punya HTTP punya server. So saya punya browser ni adalah HTTP client. It will access the server. So this is client and server model. But it is not but it doesn't mean that we doesn't have other type of communication model. So other than client and server model, we have what we call as peer-to-peer, P2P. So for example here, so nampak ni recorded lah, tapi is it okay if I showing you the BitTorrent punya protocol walaupun dia agak illegal sebenarnya, tapi I think kamu pun semua dah pakai kot. So contohlah you guys nak download, tak illegal kalau saya download benda-benda pirate, you know, for example like movies or game, yes, it will become illegal. But sometimes they not all things that I download from torrent is illegal. So contoh macam kalau saya nak download you know, ISO file, contoh macam saya nak downloadkan Ubuntu server punya file kan. Tak semestinya kita download menggunakan FTP ataupun HTTP. Alternatively, I can use BitTorrent. So BitTorrent ni dia sebenarnya bagi saya lah lagi cepat, pasal dia lagi laju. Contoh kalau kita nak download using BitTorrent, instead of kita download, you know, macam biasa we click dan dia download gunakan browser dia gunakan either HTTP ataupun FTP. Yeah, we can do it, but you can do it, but another alternative way we can download this thing is by using BitTorrent lah. Sekejap how to download. So I can use BitTorrent. So for example, if I want to use it, then I can use. So yeah, so this is one of the BitTorrent punya client. So in BitTorrent punya protocol, in a BitTorrent protocol, there is no such thing as server and client. So in BitTorrent, everyone is a server, everyone is a client. Pasal dia adalah decentralized. So that's mean that for example, if I have, for example, here is Kali Linux file here dalam bentuk OVA. So here for example saya dah habis download. So when I'm downloading, I become a client, but later on if I finish, so that I can see, so there ada konsep seed. Seed kat situ di mana saya boleh share pula benda yang saya dah download. Nampak tak? Itulah peer to peer. Maksudnya now bila saya dah download, saya seedkan supaya orang lain pula boleh download daripada saya. Nampak tak? So dia decentralized. Dia tak ada one singular server. So that's why people abuse BitTorrent punya protocol so that they can download apa? Pirate stuff. Kalau siapa yang kaki pirate kat sini, download game pirate, software pirate. Why authorities difficult to keep track on this? Because it is decentralized. Contoh, if for example the authorities take down my PC, there is thousands of more PC having the same file. Faham tak? So that's why it's difficult. So kalau contoh saya so kalau kita tengok dekat Wireshark let's capture my Wi-Fi. Okay, kalau saya capture my Wi-Fi, right? For example, if I start to seed this file, gunakan so let's start. So saya start seeding. So kalau kita tengok dekat sini, by right we can see BitTorrent punya protokol. Ada tak? Let's try. Okay, so this is BitTorrent. So dia ada protokol own protocol itself. Dia ada handshake untuk dia untuk seed, and by right BitTorrent it doesn't follow client and server punya model. So it is a P2P punya model. Okay, dia distributed. Okay. Apa yang new one yang decentralized? So sebelum ada teknologi ni, dulu lagi orang people already use BitTorrent. So sekarang ni is become a rich. So siapa tahu kot teknologi baru which is decentralized nowadays yang orang introduce? Anyone can guess?
NFT ke?
NFT Okay, tapi NFT tu okay, what is the technology which enable NFT?
Blockchain.
Yes, blockchain is decentralized. So by right, there is a multiple nodes. So where the trust on the system itself, not because we can trust the system, but because everything is being distributed. So that is how they create trust in the network. So that is advanced stuff lah. So if later on you can do your own reading lah on blockchain. So anyhow, back to our lesson. Let's So in the client server model, so there is several steps. So for example, so this is we just recapping back. So this you already learned in PIP class, by the way. So first, when we create a socket, so first the program will create a socket. Okay, so first we will talk about the server lah. So basically server kan they want to serve the application. So first the server will create a socket, okay, using the socket function, which we will learn next week. And after that, it will bind the socket into the IP address and the server. After the bind process has been successful, the server will make the socket into the listening mode. So it will ready to get request from the client, and after that it will continue to listen. So while waiting for that, sorry, sekejap ya. Ini kok, okay kak? Betul betul. Kena ada panel betul. Tak tahu lah kak. Okay, okay kak. Okay. Okay, sorry so while the server is listening, so for the client, same, it will create a socket. Then the client, what it will do, it doesn't have binding and listening process. What it will do is it will initiate connection to the server by using the connect function. So in the connect function, we need to put the IP address and the port of the server. So once if we are using TCP, then what it will do is here the TCP will establish a three-way handshake. So maksudnya dia akan first will buat TCP sync, then TCP sync acknowledgement, then TCP acknowledgement. Dia ada three-way handshake. Three-way handshake between server and client. Once the handshake already been set up, after that, yes, we can begin to transfer data. We can begin the communication session. The client can read the data from the server, and the server can read data from the client. And the client can write data to the server, and server can write data to the client. It's both way. It's unidirectional. Okay. Once the data, when the data has been concluded, the data transfer has been concluded. For example, if we want to send 1 gigabit of data, when 1 gigabytes of data, and the file has successfully been downloaded from the server to the client, then we can use the close function, so that we can close the socket, so that we can free up the computer resources, so that it can be used by other socket and by other process. Okay, so this is what we call as client and server model. We have server, we have client. So this is known as client server model. So any question? Okay.
Questions. Okay.
All right. Okay. Alhamdulillah. So next. Okay. Last but not least, yep, we have reached the end of our slide. Slide number 10. Quite a long day today. So yeah. So last but not least, the things that you need to know in the socket programming is that there is a term which we call as Little Indian format and Big Indian format. So what it is? So in programming, so we have what we call as Little Indian and Big Indian. Okay, so why this is important, right? So the format is determine how the data is being arranged in the memory. How the data, so the Indianness is referring to the how the data is being stored in the memory. So if we are using the Little Indian format, so what it does is the lowest memory address contain the lowest order bytes, while in Big Indian format, the lowest memory address hold the highest order bytes of the integer. Okay, so let's see. I think this diagram is more clear. Yep. Indians. Yeah. So let's see from the Wikipedia this one. Okay, semua boleh nampak ke this one? Can anyone see here? Can see this?
Yes, sir.
Right. So
Yes.
let's first see Little Indian. So for Little Indian, for example, we have memory here. For example, this is the data that we want to store in memory, right? So for example, the data is 32-bit integer. So this is in hexa format. So in Little Indian, the lowest memory address, which is A, for example, this is the lowest, A the lowest, then highest A plus 1, A plus 2, A plus 3, right? So the lowest will contain the, ni nampak, dia akan, it will start from the right side. This one, nampak? 0D, 0C, 0B, then 0E. See? From the lowest memory, so the term here, from the lowest memory address contain the lowest order byte. So lowest order byte is the right, start from the right. This is the lowest order. This is the lowest ni. So like this. Okay, boleh tak untuk Little Indian? Dia akan simpan dulu from the right side at the lowest memory space. So far so good? Still flowing?
Yes, sir.
Alright. In contrary to the Big Indian, so for Big Indian is where in Big Indian, the lowest memory will contain the highest order byte. So maksudnya here the definition is where the lowest memory address hold the highest order of the byte. So instead of we start from the right, we start from the left here. So this is the data. So at the lowest memory, we will first start with the we start with the left first here. Nampak dia buat dulu this one, and this one. Nampak tak? Dia very contrary to the to the Little Indian. Did you follow so far? Boleh tak lagi?
Boleh, sir.
Alright. So why this is important for you to know? Because for your information, right? This kind of standard is depends on the hardware manufacturer. Okay, so if we are using, for example, if we are using Intel processor, which is most of nowadays is using 886 architecture, macam laptop kita lah. So macam 886 So macam contoh, if we are using Core i5, any Intel processor, like of course, majority of us nowadays, our processor is using Intel, right? Or AMD. Even AMD is based on 886 punya platform. So if we are using 886 platform, then we will use Little Indian. The lowest memory will contain the lowest order bytes of the data. But sadly, if we are using TCP/IP, kan kita nak communicate tadi kita guna apa? We are using TCP/IP, right? Okay, so if we are using TCP/IP, we are not using Little Indian, we are using sadly Big Indian. So there is some discrepancy. If we really doesn't take care of this, dia akan jadi error tau. Pasal the Intel processor will process by using Little Indian format, but when we want to communicate using the socket implementation is processing based on Big Indian punya format. So there will be error. So that's why later on we will learn in the next 2 weeks where we have a function which we call as host to network address, where we have a function that will convert from Little Indian format to the Big Indian before we use the socket. So here, for example, here I have a, let me show you. Yep, so I have this simple socket programming here. So The program is server.c. So here, for example, so here we are declaring, we are creating a socket. So later on, when we want to bind the socket, we need to put the IP address and also the ports. But this value is in Little Indian, since this virtual machine are emulating 886 platform. So this is Little Indian. So let's boleh tunjuk tak kat sini? Yep. Can everyone see here? So my CPU architecture here, see, nampak tak byte order dia? Little Indian. Can everyone see it?
Boleh.
Yes, sir.
Yes.
So I'm using i5 10 gen processor. So it is Little Indian. So but the socket itself, the socket API, majority of the implementation, regardless of if you are using Windows, Linux, and everything, if you are using TCP, it will be using Big Indian. So that's why here the port number, when I want to store it in this variable, so what it does is it will convert from the Little Indian format to the Big Indian. Nampak? I convert it. So untuk IP address, sepatutnya saya akan ada hash ni, but since I'm using the in ADNE, maksudnya dia akan bind to all IP, so it doesn't matter. But later on, if we want to bind to the specific IP, we need to put this hash tone. Kita kena convert dulu daripada Little Indian to the Big Indian. Okay, boleh follow tak so far? So this is what conversion been done. The format Little Indian ke the Big Indian. Following so far? Alright.
Yes,
Yes, sir.
So saya nak tanyalah soalan cepu mas if everyone know. Ada tak processor ataupun komputer using Big Indian? So anyone can guess. Siapa tahu? Ada tak processor yang gunakan Big Indian? Anyone want to guess?
Xeon.
Xeon. No, Xeon the X86, so they still pakai Little Indian di Intel.
Huawei.
Good try. COVID? Apa ni? Okay, contoh kalau kita pakai Android kalau contoh kita pakai our mobile operating system. For example, nowadays pernah dengar ARM? Yes, Motorola, yes. Motorola so Motorolanya processor. Contoh Motorola processor adalah dulu lah. So Motorola processor is for example here Power PC ke, they are using Big Indian. So if we are using Big Indian, so nanti kalau kita tengok dalam programming kita, in our programming, we doesn't need to convert. Even kalau kita convert pun, dia akan no operation, dia tak ada function pun. Dia memang dia akan kita convert pun dia akan dah memang dalam Big Indian. So we doesn't need to do it. But since majority of our PC are using Intel, so we need to do the conversion. Another one is very famous processor, if you guys ever heard, ARM processor. So this is on the rage nowadays. So ARM ni dia adalah reduced instruction set, di mana dia been used by many of the mobile application nowadays. Dalam Android, dalam Apple computer. So most of this based on kalau kita pakai Apple A5 ataupun kita use the newer silicon, which is Apple M1 punya processor ke anything. If it based on ARM, right? So ARM, the good news is it can do both. Dia boleh buat Big Indian, dia boleh buat Little Indian sekali. Dua-dua sekali, right? So if we are using, maybe if we are using socket programming, for example, in Arduino, for example, if we are using in embedded system, right? For example, Arduino, or if we are using on in mobile application Android, we doesn't need to do the conversion if we are using socket API. Doesn't need, because it can do both. ARM can do Little Indian and Big Indian. But by default in ARM, it will use Little Indian. So inilah, so nanti later on when we do programming, so we can see lah how we we're going to do the conversion using the question. Ada question ke tadi?
So ARM ni which is better than Intel dengan AMD ke?
Okay, kalau better kan, kenapa kamu punya gaming PC tu tak pakai ARM? Kenapa tak pakai apa ni? Kenapa tak pakai uh, Samsung Exynos ke kenapa?
Tak tahu.
Okay, anyhow, pasal 886 maksudnya complex instruction set ni macam Intel, dia dah ada leap forward tau. Maksudnya dia dah lama. Maksudnya banyak program dah tulis dia memang dia dah dia dah native dalam 886. Dan 886 ni kamu tengoklah. Dia ada 10th gen iCore dia ada AMD, dia ada Intel. So they have incorporated all of these advanced teknologi dalam dia punya processor. So walaupun in design, so kalau kamu, if you guys are learning computer architecture, actually reduced instruction set such as used by ARM ni actually is superior compared to complex instruction set such as 886. So that's why people say that this is superior. But as of now, there is no ARM processor that so far can overcome the performance of 886. But later on in the future, we never know. And have you guys heard about Apple M1? Ada tak dengar yang Apple launch dia punya own silicon M1 processor? Let's see. Tengok Apple dia ada baru dia tu
iPad ke apa.
apa kan dia apa entah dia cakap the most advanced lah apa kan. Itu based on the ARM. Dan Apple claim dia punya processor punya performance is better than Intel punya 886. But bila orang buat benchmark somehow tak lah kan, dia tak. Tapi somehow in the future we can see that along the line ARM processor will become better and better and better. Maybe one day it will overtake the performance of Intel based 886 punya platform. That is a sure now. That's why Apple is doing it and everyone is now developing a processor based on ARM punya platform. So tak silap saya M1 Max ke M1 Ultra. Yep, this one. So they Apple claim lah somehow their latest advanced silicon based on ARM architecture is better than Intel punya. Tapi so far what I'm seeing is not lah. So far tak lagi. Tapi in the future we never know, right? Yeah. So I think that's all for our lectures today. So I think that's conclude everything that for this week lecture. So before I let you guys go, so do you guys have any question for me? Is it okay? Did I talk too fast?
Okay je sir.
Right. Okay. So kalau tak apa lagi, dan minggu depan we will cover on more technically about the programming itself, how we going to use the Unix socket programming. And I hope that I can see you guys next week. So thank you again for coming to this collaborative class, right? So I really thrilled that we have students from UGM, University Gajah Mada, and UiTM, sitting in this lecture. And I will share with you the recording of this lecture if you guys want to see back this, you want to see back this recording, right? So before we end our class, so please make sure that everyone already put their attendance, right? So let me send it again. Yeah, so I already put the attendance at the chat box. So please do fill up your attendance. So if you already fill up, so Assalamualaikum. So selamat berbuka, happy Ramadan. So I see you guys next week, right?
Waalaikumsalam. Thank you sir.
Thank you, sir.
Salam. Thank you, sir.
Thank you sir.
Okay, thank
Thank
you.
you, sir.
Thank you, sir.
All right, thank you.
Thank you sir, selamat buka juga.
Buka.
Thank you sir.
All right.
Thank you sir.